simultaneous equation. Now, in our previous session, we've been able to look at solving simultaneous equation using the substitution method and the elimination method. So, we're going to take some technical questions or some strategic questions in which simultaneous equation could actually be tested. Now, let's take a question on this wise. A question says, this is actually a question that have to do with a combination of simultaneous equation and the rules of indices. You can say that's something in mathematics. All topics therein are intertwined. They are connected to each other in one way or the other. And it will be expedient to have a very concrete knowledge of the foundation, peradventure in this case, indices, so that as be able to solve questions in advanced levels. So, the question says, find the value of x and y. Find x and y. If 3 raised to the power 2x minus y equals to 1, and 16 raised to the power x all over 4 equals 8 raised to the power 3x minus y. Tends to be a bit difficult. No. Now, when you see a question like this, first thing, you don't be afraid. You actually, even not only in academia, in professionals, in any question you are actually faced with, don't ever be afraid, irrespective of how ambiguous the question could be. The only thing that the examiner needs you to do, there's no question that is that, it only depends your ability to interpret correctly, and then to be able to apply governing principles adequately. That's just it. So, irrespective of how ambiguous a question could be, it only needs you to be able to break it down, decipher the technicalities behind it, and then be able to approach it within the periscope of the principles that are governing the topic. So we move on by saying we could actually expatiate equation 1 further by saying this 3 raised to the power 2x minus y equals to 1. Don't forget, I told you that anytime you are solving indices in questions, find all mediums to convert the basis to the same base. Find all medium to convert all to the same base, so you could actually equate the powers. So we have 1 is the same thing as 3 raised to the power 0. You can actually equate this further by saying, equating the powers we have something like this. We cut the basis, and then we eliminate the basis, and then we have 2x minus y equals to 0, equation 1. Simple. This is actually what the examiner is trying to write, but is looking for a way in which to test your technical ability and intellectuals. So let's do the same to equation 2. To the second equation we were given. So we have 16 raised to the power x all divided by 4 is equals to 8 raised to the power 3x minus y. Now let's convert all to base 2. In this wise, we are going to be having 16 is actually 2 raised to the power 4. Then we put in bracket x all divided by 4 is actually 2 raised to the power 2 equals to 8 is actually 2 raised to the power 3 in bracket 3x minus y. So we have something like 2 raised to the power 4x all divided by 2 raised to the power 2 equals to, open this bracket, and then we have 2 raised to the power 9x minus 3y. And then we have something like this, 2. You will agree with me that we could actually write this by saying 2 raised to the power 4x minus 2. Am I correct? Yes. Division changes to minus. And then since the bases are the same, we could actually pick one, and then we take this power up and we change the division to minus. So it's equal to 2 raised to the power 9x minus 3y. So on this note, we could actually equate the powers. So we eliminate the bases, and then we have something like this. And then we have something like this. Equate the powers. So we're going to be having 4x. We're going to be having 4x minus 2 is equal to 9x minus 3y. So if x comes to this side, we did be having 9x minus 4x minus 3y equals to minus 2. So we simplify further by saying this is going to be 5x minus 4x. This is going to be 5x minus 3y. And then we have equals to minus 2. In other words, we could write this as 5x minus 3y equals minus 2, equation 2. Simple. So if you note now, we are now back to simultaneous equation. Initially is an indices, but now we've actually solved it down. We've simplified it further to give us a simultaneous equation. And then we have the two equations to be what? 2x minus y equals 0, which was our equation 1, and 5x minus 3y equals to minus 2, which is our equation 2. So on this base, we could actually use any method: graphical method, elimination method, or substitution method. But let's use substitution method since we have an unknown variable with a coefficient of 1. So using substitution method, we say from equation 1, y comes to this side, that's going to be 0 plus y. Then we have 2x on this side. So y is equal to 2x. So anywhere we see y is actually a multiple of x in 2 times. This is our equation 3. So we say substitute 2x for y in equation. We've used equation 1. We've gotten equation 3 then in equation 2. In equation 2. Substitute 2x for y in equation 2. So we move to equation 2. Anywhere we see y, we substitute 2x. So that's going to be 5x minus 3 into brackets y is 2x, is equals to minus 2. And then we have 5x minus times plus, that's minus 3 times 2x, that's 6x, is equals to minus 2. So therefore, we have 5x minus 6x, that's going to be minus x, is equals to minus 2. Minus cancels minus, therefore x equals to 2. So from this we say substitute two for x in equation 3. Still remember when we were doing in our previous session, substitution method, it's always best to substitute directly into equation 3 because it already have an equation that will give us an absolute answer for the remaining variables to find. So to move on further, we move to equation 3, which says 2x is equals to y. Therefore substitute 2 for x, and then we have 2 into bracket 2 is equals to y. Therefore y equals to 4. That's the final answer. Therefore x equals 2 and y equals 4. You can check by going to the previous, to the initial equation given. Actually, we could actually check for this by using any of the initial equation given. The initial equation given is 3 raised to the power 2x minus 1 is equal to minus y is equals to 1. Now let's substitute these figures into x and y and see if we are going to get 1. So this is going to be 3 raised to the power 2 into bracket x. X is actually 2. So that's going to be 2 into bracket 2 minus, what's our y? Our y is actually 4. So it's equals to 3 raised to the power 2 times 2, that's 4. 4 minus 4, that's going to be 3 raised to the power 0 equals 1. So, thank you. I believe we've been able to get this.